This is a have and want network that controls a stepping motor. It's made of 17 fractals that connect a stepper motor at the bottom to some higher intelligence at the top. Fractals connected in this way resembles a tinker toy contraption, each knob doing a little bit of computation. This network has 4 different kinds of fractals, each performing a specific function which we will describe. Each port of a fractal is linked to some port of another fractal above it. Links carry signals in 2 directions. They contain a have signal going up and a want signal going down. Let's focus on the operation of one cycle just to get an idea of how these simple elements work together. We think that much more complex networks work similarly. We start with a fully formed network that was previously learned experientially, as shown in a different video. We'll start with the motor's pole in position A. The have signal for A is shown in green as it comes out of the sensor going up. It says in effect we have evidence that the pole is in position A. This goes to a previous unit. In this action mode, it just forwards its have to its T or current port. Next up is a broadcast fractal whose function is simple. It duplicates the signal, sending a copy out each leg. Each have goes to a Hamming fractal, which is trying to detect a pattern. This Hamming detects that one leg of its pattern matches. It and 2 other Hammings connect to the maxor gate above them. The maxor forwards the maximum have upward, telling the higher intelligence that it has a partial match for the forward condition. The other leg of the broadcast goes up in a similar fashion to the backward link. That's the way the have signals go up when the pole of the stepping motor is in position A. Now, when the higher intelligence wants the shaft to spin forward, it asserts the want on the forward link. The want goes down the maxor, which forwards it out the port with the biggest have, down to its Hamming. The Hamming wants its pattern to be satisfied, and this is best done by asserting the want to the unsatisfied leg. If that were to be also true, its pattern would be totally satisfied. At this point, the want going down follows a different path than the have going up did. The want from the Hamming goes to a broadcast fractal, which heads the sum of the wants down to the previous fractal of position B. In this mode, the previous fractal forwards the want to the stepping motor, activating a coil or something, and spinning the stepping motor to position B. After the spin, the have signal goes up a different path for position B. If forward is kept asserted, pole C will be wanted, and the motor will spin again. With forward continually asserted, the motor will spin indefinitely. By similar reasoning, if the higher intelligent wants reverse, the shaft will spin in the other direction. Thus we have shown how a bunch of simple fractal parts, tinker toy-like things, can connect over bidirectional links and control a simple function. In another video, we show that most of the fractals in this network, actually all of those above the previous fractals, can be learned experientially. These kinds of have and want fractal networks can be very powerful if one assumes that much more complex functions, perhaps all of animal common sense, can be learned and made to act in this way.